Today we'll be talking about MLOps in Snowflake, mostly focusing on the core component that made easy within Snowflake. And we'll be focusing mostly today on how you manage model throughout your journey of ML from your development to production. Before we begin, there is some legal disclaimer about all the future-looking features we'll be talking about today and the dates associated with it. First, let me introduce myself. My name is Sumit Das, one of the engineers in ML platform team at Snowflake. And to emphasize all the product we'll be showing today, we have invited one of our esteemed customer, Invista. Please, I am honored to welcome Vamsi, who will showcase how this product is used in production in Invista and made life easier and simpler for our customers. Today's we'll be going over MLOps and model registry, what is there, why do we need it, why it is important for your ML journey. Then we'll be introducing model as a first-class entity in Snowflake and what Snowflake adds value by making model, bringing model into Snowflake. Finally, we'll go over a lot of ways you can manage them, you can push them to production, and we also believe that it is not one size fits all, so we'll show you a lot of options. This is a 300 series talk, so you will see a lot of details about managing your models. And finally, we'll end with a case study which Vamsi will be presenting and showcasing how model tracking and cost oversight was simplified using Snowflake tools. So let's start with a pretty old but still relevant paper published by Google. This is called Hidden Technical Debts in Machine Learning Systems. The key takeaway that brings in this paper is only a fraction of ML system is actually composed of ML code. It involves a lot more than just the ML code to make a system running end-to-end flawlessly. This has been a well-known technical debt in regular software engineering where we had to deal with code and the deployment environments through a robust release process called DevOps usually. But in ML, things have changed. We introduce data and model, and that depends on iterations, not really cumulative code that you can just keep on merging and release with some testing. So iteration is key, and let's talk about iterations. This is the basic of machine learning iterations where you start the training process with the data, you clean them, prepare them, and then train, evaluate with your own test data, and when you are comfortable, now you push it to probably production, but your job is still not done. You are again iterating in production, looking at metrics, constantly looking for skew and many other things. Lot can go wrong here, and specifically, you probably want to capture all the intermediate states of your iteration so that you learn from it and improve in your next iteration. Faster iteration is the key and key to the success, and I am sure everyone understands that very well here. Now, the main key here is that how can we capture these intermediate results, and this is usually called ML artifacts, together with your governed data, and how much can you automate that to make it more seamless and easy to make your iteration faster. Lot of things can go wrong. There can be a lot of silos between your data sources and between the training data and preparation you have done. From training environment to inference, when you run in production, a lot of data can change. So capturing this lineage and object dependencies automatically is the core requirement for this system. And that's why we believe Snowflake is the best platform for you to bring your machine learning end-to-end system where your governed data sits next to your ML artifacts. A lot goes in MLOps. And if you look at in the subsequent steps, most of the things pivots around a model. So you first did training and you produced a model, but then journey becomes even harder to track it end-to-end in your production. It starts from inference, but then you do lifecycle management, lineage, governance, sharing, or monitoring, right? So model registry or model is the central piece. This is the handover between your development and production. And that's why model registry is a key piece in your MLOps journey. The first and most significant step in your ML journey would be to bring that model into Snowflake and gain all of the features we have built, and it works seamlessly with rest of your data at Snowflake. Without further ado, I would like to announce that Snowflake Model Registry is now generally available. It is available in all cloud, all regions. To make it easy for you to use it, we have provided simple to use Python API that we'll show with a live demo today. Then we have a full-blown SQL support for your all model related operations, and you can use your favorite worksheet, Snowflake CLI, any connectors, and it will just work out of the box. We have supplemented it with easy to use browsable model registry UI in Snowsite. You can do simple tasks, you can browse models, all the models that you have access to. To make things better, we also made it very developer friendly. So we support a growing list of model types today, and we also provide you to customize for your custom model types that may not be supported directly out of the box. Where does it fit? So we have a simple no-code, low-code studio offering that goes through out-of-the-box ML functions, and it runs in our flexible compute on the warehouse runtime and container runtime. But model registry supplements the other side, where developers want to build their own code-first ML solution. You want to manage your code, you want to manage your artifacts, and to supplement that we have feature store and model registry to manage your artifacts, and ML modeling library helps you do the training all within Snowflake. All of these libraries together works and takes advantage of extensible platform that we have offering warehouse and container runtime. Who is this for, and what value does it add, this model registry? So there are three kind of personas. One is model developer. So they are developing model, generating model, creating model, training day in, day out, and trying to manage their metadata to see which model is the best, right? So this is done, and for that we have very good Python APIs and metadata management system. For production engineers, it matters to manage the life cycle of model from your iterations to production. And that's why we have a versatile way of many ways you can manage life cycle of a model. We'll showcase that also later today. And then comes application builders. You just use model as a component of your application. You do not want to worry about how to serialize the model, how to ship the model with your application, and that also can be done very well with your model registry. And you can focus on your business logic while model registry takes care of the serialization of your model. How does it work? You can start from Snowflake Notebook, which is just one browser tab away, or you can use your whatever IDs you are using. And from there, if you can use modeling API that lets you train models inside Snowflake. If you choose to use any other SDKs, feel free to use. We support a vast range of libraries for model registry, and we also, this list is constantly growing. Then all you have to do is just call a log model in a Snowflake ML library SDK, and model is in. Model is inside Snowflake and inference ready. You can run inference on warehouse without any extra step. So this is, so key point of this slide is that you do not have to change your environment. You do not have to change your habits. All you need to do, import Snowflake ML and one statement, log model. I'll show you that shortly. Let's go into what is a model. We talked about model is a first-class entity at Snowflake. So it's important to understand what it is. So model is defined as a collection of versions. So it is explicitly versions. Unlike other objects you might see in Snowflake, be it table, views, and other things, version management is implicit. You do not control. Latest is always the greatest. But no, for model, it is explicitly versioned. You manage your own versions within a model, and you can manage the life cycles yourself. A version is actually the real version, real model that this is a result of your training job. It contains a lot of metadata and metrics. They are mutable, you can change, update. But what is key here is, once model is logged, its inference functions are backed by files and immutable. You cannot change them, and this gives a strong guarantee how you can use model within Snowflake, share, and still you get the same results out of it. This is backed by files, so you can see, you can list all the files, you can download all the files. So we support all the stage APIs to get your files back, And we have invented a new URL, Snow URL protocol to show or retrieve your files from model. Okay. So this is now demo time. Let's see our Python API in action. So I'll start with our quick start guide, where we have done a training. We have a data set with diamonds, which gives you carat, color, clarity, depth, XYZ, and we try to predict the price of the diamond. Here we are starting with a data set. This is a new concept we introduce, where you can create a immutable data from which you can repeatedly train, and then you can compare against a same data set, same numbers, so that you can compare your models. So we start with a data set here, and I am using the version 2 of the data set. You can see data set is already printed and it has all the data. It's just accessible like data frame you do today in Snowpark. Moving on to the training. So we are using XGBoost trainer here, XGBoost regressor, and this is a modeling API. So it takes care of a lot of things for you, and it imperative code automatically pushes the data into Snowflake warehouse. So you already know that, and I have already trained this model, and you can see there is a result. It has some plots, and we have also computed an error we got from this. Now this result, the error is almost 0.2, you can see over here. Let's move to real model registry. So first step in model registry is you create the registry object pointing it to a schema. That means all the models will be logged in that schema. Now, first step to pull your model is just log the model. So we are just logging the model over here and saying let's log with version 1. Just for simplicity, I also logged this model twice, because so that I can show you multiple versions management. But I did not train the model again. So for this demo, I am just using 2 versions. Both are actually same, but we are treating them as different. Moving to using the model. So the strong API that we are talking about, but simple, intuitive, starts with very simple. You want to browse your models. So let's run them. So you see all the models you have. I had created an old model and then I copied it, so you can see both the models are visible, and it is giving all the information on the right side. Let me scroll it. And it is saying what are the versions it has, and it is also saying which one is the first version, which was the default versions, and everything. You can just retrieve this model by doing get model. What it does, it doesn't get your model downloaded or something in your client. All are happening remotely. You are just getting a reference to the model. You want to update a description, just go ahead and update it. Now let's see what happened here. So our original model did not have comment here, it was none. So it should be automatically updated. Let's see. Yes, it is updated. So basically what point is, the API is dead simple, and it does behind the scene everything at Snowflake. Now coming back, you can see the versions of a model, and you can see we have created 2 versions, and one is 1.0, another name I did not put a version, so it automatically generated a version name for us, and this is in this case ironically made weak Python. Let's mark the Python version as default. So you can see here, currently this is the default version. So whenever you create a version, it automatically makes default. We can change anytime which version is default. It's one way to managing your versions. Then you can see again the versions have changed, default has come here, and now coming to the referring a version, now you want to use it, right? So I will choose one of the version. You can choose this directly, and again same thing, you can see we have chosen this is the version, it gives you all the metadata, but it is not still the real model, but you are just getting a reference. We can update the description same way. I will not show so much. Moving on, this is the most and key piece here. I mentioned that a model is inference ready as always, right? So that means you can use it directly without any further step. So first step to do, I want to know what are the functions this model exposes. In this case, it was a modeling API, XGBoost regressor. It exposes predict method. And it also tells what are the inputs it takes. It takes all of these inputs. By default, our modeling API also will echo back the inputs in the output for convenience. So here you can see all the inputs again echo back, but predicted price is extra. We are emitting from this. Now we know how to call this model directly, right? I'll call it right away. So I have a test data frame I can run. All you need to do mv.run, and it will run all remotely in Snowflake, and it will return you a data frame. You can print the results, and you can see it has printed the predicted output here. Moving on, if you want to just call on the default, you do not know the version, you do not care about the version name, just call m.default.run. It just works out of the box. Let's move on to metadata management. We talked about that you can manage metadata in Snowflake, and we have a simple API for those. Those of you who are using tags, you can manage tags directly from the Python API. You can see all of these. There is no tags at this point. And then I'm just setting the tag, and now onwards you can start seeing the tags happening. Same thing happens with another set of metric that we have is called update the metric. You remember we have said that you computed metric, and we are just putting the metric back. So you can see all of this you can do from the Python layer. Let's moving on to the model that you put in. Is it lock-in? Absolutely not. You can get back your own model back from Snowflake. So I'll just try to show you what we can do here. You just need to point your export function to an empty directory. It will download all the content so that you can take them in wherever you want. So you can see we have a lot of files written for this model automatically, but main thing and key here, for XGBoost you use Pickle, for many others like for example TensorFlow and PyTorch you use whatever that framework provides, maybe safe tensors and other things. But this is the main model file, and we have automatically captured the requirements and other things so that we know how to run exactly in warehouse, and in the future how it to run in SPCS. If you, for any reason, need that model to be rehydrated in Python, we understand that it is needed. There are a lot of libraries like SAP and other Python SDKs requires you the real model Python object. How will you rehydrate that? That also possible through mv.load. So you just do load it. It will bring the same XGBoost regressor model in your Python environment. What it tells you here is that our model loading is a little bit risky. If you logged a model in 3.8 Python, you must be loading it back in Python 3.8. So that's why it is giving you a warning that note that your environment where you're trying to rehydrate must be the same. And just to showcase that this is the same object which is printed here, I can do also dir, and it will see the same sets of APIs are exposed by is. So let's go back and to our next set of Python API we are having. So I talked about how it is extensible, right? You can define your own model. So let's introduce an API for custom model. Why do you need it? There might be some model that we do not support yet. You can define it for your own use, and you can start logging it. You can also implement a small inference graph where multiple models are clubbed together to make one model for you. There you go. So the API looks like this. You first define a context. So this artifact, the first one, it basically says that anything that you serialize, and Snowflake doesn't know how to serialize, you put it and refer to a local file where you put the serialized bytes. Snowflake will take in and give you back when you need it. And these are the places where you can do all the models that already Snowflake knows how to serialize. You put them as a dictionary, and they are available automatically serialized by Snowflake for you. Now, in the inference call, here we are calling run, and we are annotated with a decorator. What is happening here, at this point, all the context are loaded for you. So you can just refer to your models, and you can do predict. So what I'm doing is a small inference graph here. I am calling two models, adding a bias, which is passed through this config file, which is computed here, and then returning it. And this API has to take a pandas data frame and return a pandas data frame. That's all you need to do to make a custom model work in Snowflake. And the rest of the code, you can see exactly same. You can do the same exact log model call, and your custom model is ready. Moving to SQL API. We did not forget about SQL when doing model training in Python and logging in Snowflake. So there are a lot of users here who use SQL, and let me show you a real demo for it. So you have all of these APIs available, and you can do models, list all the models. You can do same thing you saw in Python layer. Everything works as is. You can also update the metadata directly if you wish. You can, best part is you can do predict directly from SQL. So when you are predicting here, as you notice, we did not specify any version. So it is invoking the default version of the model. But if you choose to call different version, you can specify explicitly and run it, and you get back the result for the version 1. Note that it outputs an object because we have said it provides multiple output. And as you noticed in the previous call, I made a predicted price and it was automatically extracting that one for you. Moving on, we have same thing you can do here. You look at the files that you saw from export, same thing available in SQL layer. You can do get and you can download yourself. Finally, the best part of Snowflake is you can query your own metadata. So you have managed lot of models and their versions. How you can query them, you can iterate over them to ask questions. So this is our information schema where all the models and its versions are listed. So you can actually query to find who is the best model for particular model type or whatever query. So in this case, I have made a query on this information schema to print the ordered by accuracy. And you can see it is ordered by accuracy. As I copied the models twice, you can see that version 1 for both the models were the same accuracy, and you can see the results. So essentially, you can query back to your own metadata, and this is the beauty of a model registry that gives you queryability and programmability to you. So let's see now, we didn't stop there. We also have a very intuitive Snow site that gives you ability to browse models and inside Snowflake, and it takes care of your access control, and it only shows those one that you should have or you have access to. Let's see in action directly. So all the models appears in AI/ML tab and under model section, and in this section, as you can see, we have all the models, and here is the model we just trained. If you click through this one, it directly goes into the data browser. So it is well integrated with the rest of Snowflake objects, and in that you can see we have 2 objects, and this is the one we just updated the description. We can see all the versions. They are just done trained 1 hour ago. Now click through one of the versions, you can see that we have updated the accuracy, we had added some metadata, they are showing up, and also the syntax or the function exposed by it. You can also do a lot of basic operations here like edit and drop. Let's talk about governance. There is no Snowflake without governance. So it allows, now you have a model already in Snowflake. You can do all sorts of sharing and all sorts of access control on it. So as an owner, you have access to everything. You saw files, you exported the files, you download, you loaded, dehydrated. As an owner, you can do everything. Now you grant usage to the model to another role, let's say prod role. Prod role can do inference, can do all the read-only operations to figure out what the function it exposes, and what are the versions it exposes, which one is the default version, and it can call inference. But it cannot alter your model. It cannot also see the artifacts. So you can securely share without exposing your model weights to anyone you want just by granting usage. To do so, I'll just show you here. You can see as a owner of the model, you can just grant the model, you can see the files showing up. But let's say as a prod user, you want to predict, you should be able to inference, and it is running right out of the box. But if you try to see the artifacts, you are not allowed to. Let's go to the most important subject matter today, iteration to production. We understand there is a lot of needs, how you want to push your model from your development to your production, right? So we also realize it is not one size fit all. So we have various ways you can manage your versions. Let's start with simple one, default version. We already showed in Python layer that how you can set and update default versions. And then you do when you predict, and default version will be predicted automatically. So you do not have to change production code. You can just switch from one version to another. You just graduate the new version to production. Next comes alias. Let's say you have 2 production environment or multiple. One is canary, another is live. So in live, you want to call the live model, and in canary, you want to call the canary or staging versions. Use alias, which is another name for the version name. You just can point to any version and you keep on changing, and you can do that. Then comes, I want to control who can change this canary live and all of these versions. I want to control more. I do not want the owner of the model to change the version I use in production on me. So for that we have tag. You can point a tag mentioning a version and set on the model level. And you can refer the tag back by get tag, system get tag if you know already. And we support this identifier protocol here that it will work just out of the box in SQL for inferencing. And then final, we'll be talking about copy out. We heard from customers that we have a lot of setup differences. In production, we use a different database or schema. In development, we use a completely different. That's fine, absolutely fine. You develop in your develop schema and then copy out selectively whichever model you want to graduate to your production directly to the prod model. So you can do create or alter model, prod model, and then copy from a model, and you have a separate copy of the model. Finally, we talked in the beginning that we automatically capture your iterations. We said there can be a lot of silos between data source to training to inference. And here comes lineage. Whenever you try and do model training using dataset or create a dataset from tables, everything automatically captured in Snowflake through lineage and object dependency. So here you can see data source. We are using that data source is used in feature views. This feature view is in this training set, and finally this is the model we trained from this data set. Everything gets captured automatically. Let's see in action. This is a complete new notebook. I just cleaned it up. As you can see, I am referring to a model version, and now this, if you remember, this model version was trained before. I showed you previously. Now you want to see where from this model was trained. You just query the lineage of this model, and you can say it was trained from this training dataset version v2. In fact, you can load the version dataset automatically directly in the code without knowing the name of it. You can just go say load from lineage, and it will load the dataset version for you. This is the original way we have done in the training time, but you do not have to do. Once model is trained, lineage is captured. You can also read the dataset directly. Sorry, I did some edit. Okay, I can change it. Sorry. You can read the dataset, you can see the results, and directly showing up same thing. Now you want to do more. You want to know what are the models trained from my dataset. You can query again Snowflake. You can query directly saying that I want to know. And as you can see, there are 4 models because I copied one and logged 2 other models. All of these are coming from this dataset. And it is telling, here I put 4, but we didn't capture anything more than 1 level, so it is showing only 1 level here. Distance is 1, and this is downstream from the dataset. So as you can see, we did not write a single extra line of code to capture this lineage. It's all automatic within Snowflake. And now we are also giving you programmability by giving you the raw data so that you can do your own UI if you wish. And you can see the lineage yourself directly using, in this case I am using GraphViz to plot this. But point is, you have access to the data. You can do whatever programming on top to deliver results or value for you. Going back, you can see also lineage directly in the UI. You remember model here, you just click here, you should be able to see it. So as you can see, this is the model. You can see we are talking about version weak Python was trained from a dataset v2, right? So everything all within Snowflake, automatic without a single line of code. So with that, I would like to hand over to Vamsi.
Thank you, Sumit. Thanks everyone for making time to join us. I will start with, we really enjoyed our experience, incorporating Snowflake into our MLOps for recently. And before jumping on to what, showing what we had done in Snowflake, I'll introduce what we do. So we are in Vista, we are a business-to-business materials company, a chemical company. So we are part of a larger company named Coke Industries, not the Coke that comes in your mind when you hear. And the core products that we make is, as the list says, chemicals, materials, and fabrics and fibers. And that basically goes through everyday items. And some of them would be carpets, toothbrush, razors, airbags, most of the airbags in the cars that you see, and all the carpets that you see everywhere. And And we manufacture close to over 300 products and 300 and also intermediates that goes into different products that make that other companies manufacture to more products. So to basically do data science and build value for the company between products and between manufacturers, we had to have a robust MLOps pipeline that's easier in terms to go from experimentation to production in lot less time. This is the architecture that we had right before Snowflake, right before us investing in Snowflake and spending time to build our MLOps. And this is the final version, but it has we had only grown into this. Not this is not something that we had started with. Where being a lean data science team, we were using SageMaker as our experimentation platform, where we're bringing all the data that was already in Snowflake into SageMaker to do all the experimentation. I would also point out the reason that we had to move to Snowflake is also that as the data has gotten only bigger over time, it didn't make sense for us to bring the data to the compute rather than the other way around. Just putting it out there. And this is just a simple flow of going from experimentation to how do you productionize and do inference, and also accounting for it more on the model governance side. So here, what let's just skim through what we are doing here. So once we from a data science team, we are happy with the performance of a model. We have built our own infrastructure as code deployments for both model training and retraining plus inference. So we basically repurpose the code that we built on the experiment side on these two frameworks, and they run, and our orchestration happens through GitLab Actions. And we store most of the metadata and artifacts that we store in S3. And another piece that here that I've highlighted is our visualization and more SME dashboards are used to be in Streamlit as well for some time now. And the only thing that I've highlighted as red is the model governance that we're going to talk that Sumit has focused more on, is where the reason for us to highlight that as a piece is that it has a number of reasons, but the main thing was we as a data science team always has went behind anecdotes as a value, saying a customer saying, your predictions or analysis has helped us sometime last month, but there isn't any tangible way to bring out value from it, saying X dollars has helped and such. So for us to have a single source of truth, where having predictions plus the ground truths did really help. And also the secondary thing to that is also measurables in terms as such. How much money are we spending on building this certain model for this particular business verticals? Let's say we do a project for manufacturing and we spin up a project. How much are we spending from a cloud or a compute side, or even from a data science team technical standpoint, from experimentation to production? So I think that's where model registry and object tagging. I don't think we have touched on object tagging, but that's also some best practice that we follow along with model registry to track how much Snowflake credits that we are burning through going from experimentation to production. And we just basically visualize that over Streamlit, and this is what we had before. And just visually inspecting this, you see a lot of a big fragmented style of development going from experimentation to your code basically hops through 3 different levels to get through it, and it's really hard to track number of models in production and all those seamlessly. So kind of zooming in on specific model tracking and model governance piece, we did try to solve it before even going out there and trying out different MLOps platforms. And we tried to build our own cost mapping and tagging using storing all the model metrics that we are building in S3 and here and there. But the vertical aggregation going back to going back to different business vertical was really an issue, considering because we do our experimentation in SageMaker, and our ML models are deployed in Lambda, and our more advanced models are deployed in Fargate. So we were able to get the cost aggregate for each and every one, but it isn't easy to point it out to a specific one and then aggregate it back. So and kind of as I talked about, and these are the main pain points we tried to solve using Snowflake, is that as there is infrastructure as code and all those GitLab CI/CDs has involved, it kind of goes above a data scientist's roles and competencies. So that's where we were more dependent on other teams like cloud and architecture, which was a drag sometimes. And you see multiple platforms here and multiple services, so there are a lot of points of failure for us. And no structure in experimentation to deployment, so there wasn't any universal structure that we were following. So we do experimentation however the project problem statement demands, and then we go from there. So there wasn't a universal structure that we were following for ML or different projects, and then even deep learning. So, and less measurables, as I talked about. There wasn't an easier way to know number of models in production, how much are you spending, and also aggregating it back to business vertical and cost center. And this is the architecture that we had for ML, but for deep learning and other first principle type of models, it altogether needed a different architectures. And the model retraining was in a more DevOps style than the more iterative MLOps style. So the current architecture, which is a more simplified architecture, which we had to do it for the summit because of the visibility. But there's another webinar that we had done with Snowflake a month ago, which had more detail to going through nitty-gritty things, which I will include in the next slide. But here it's more simplified. You see. Most of our data was already in Snowflake, so we didn't had to move it out of Snowflake. And then we were using most of the machine learning, we use tree-based models because most of our data is non-linear, and we were using Snowpark ML to build the model. And it only made sense is the API is pretty simple, and the hyperparameter tuning that we were doing in Snowflake was already distributed in nature, so it's way faster. And we were storing all, as Sumit has shared it with us, we were storing all the artifacts and metadata in model registry in terms of top influencers of the model, why a certain prediction, and all those as well. And the top line is the model training piece, and the bottom line is more around the cyclical, the inference phase, where we use streams and tasks. So streams is basically looking at the continuous data capture on a certain table and taking those added records and using the best model in the registry to do the predictions and aggregating those predictions back. And we do all the model tracking and visualizations in Streamlit now inside Snowflake, where as model registry and object tagging each line of the way is already tracked, it's easier for us to quantify the number of Snowflake credits burned through a certain project. And all these happens in a single platform and through Visual Studio. And some of the other best practices that we had incorporated is having a universal file structure for all of them with inbuilt common Py scripts that you generally use, like imputation or feature creation for certain businesses, and everything built out, which we try to use universal throughout any project that we do. So there is accountability throughout the way. I already can see two big changes that I'm going to make for this architecture in terms of using dynamic tables more than the streams and tasks, and also using feature store rather than the traditional way. So right out of the bat, we have seen the value more around having a universal structure in going from experimentation to deployment in just one platform, and it's easier to measure. So, we're bringing compute to the data, and the main thing is the greater visibility for business on usage and how your team's, creating value, and custom alerting for failure. So this is also something that I would change with the new things that came out. But we were using mostly a stored proc call of send email to send out emails out. But looking at the Snowflake trial, I think I'd probably will use the event logs and then build alerting on top of that. Or even, there's I think a new thing that came out for Snowflake Tasks API, and ease in orchestrating DAGs. So our retraining and all the pipelining the scripts was more harder previously, but right now using a Snowflake Tasks API has made it way simpler to orchestrate different scripts with good precedence. And this is the link to the webinar that has, I've had to skip through many details here, but this webinar has all details around what file structure used, what best practices, and what is different scripts that we were using to make it go from start to end, and how do we track and stuff.
As you see that our products are very intuitive but powerful, and it makes a lot of changes and simplicity to our customers. Let's summarize. So what we have seen, we saw easy to use intuitive API, we saw performance and scalability, all models are inference ready, and you saw how can you discover your models, you can query them, you can find short, and you can do everything. And then we have seen governance and security, how you can do like share your model securely without leaving it exposed. And then we also see, we did not see a product that is just works in isolation. It is fully integrated with single Snowflake product. It works with existing ML, modeling, feature store, data set, everything together, and it just all looks like a single product, one place. That's not all. We are continuing to improve this. So as we touched upon in the beginning, that we are working on something that model is easily runnable in also container service. You might need GPU access to your model. You might need PEEP packages that are not available in your Conda. For that, we are working hard to make model deployment as seamless as possible with the same Python APIs to be runnable in Snowpark Container Service, and you can directly query them. So second, we are working on replication. So if you have multiple deployments, you are replicating one from another, we should be able to run your model in secondary as another auxiliary compute, and you can get the same value. So we are working on that as well. Finally, we are making our model registry unified across Snowflake. You've probably already seen that Cortex fine-tuned models are showing up in registry already. We are working on Doc AI and other all models to show up automatically there and manage the models like exactly the same way. With that, we should be able to get started with these documentation links, one documentation and another on this quick start. Thanks for joining.